This is part 2 of our titration. We're still working, I'll show you on the bottom. So we're going to be focusing on the second, third, fourth, fifth part, and the back, which is an example of the lab itself for titration. So the second part then says identify the ratio of hydrochloric acid to sodium hydroxide. When we write that equation out, hydrochloric acid to sodium hydroxide is a 1-to-1 ratio, and that we'll need to keep in mind for later when we're doing calculations. So our next step says determine the moles of sodium hydroxide used to neutralize the hydrochloric sample. So we know moles is equal to moles over liter. I have my molarity concentration, or molarity, how you want to say it, to moles over the liter, which I used in milliliters. So I'm going to convert that to liters. And then we get the number of moles is equal to 0.002676. Okay. Step 4 then in that process, where it says step 4, determine the moles of hydrochloric acid neutralized by this. We can, by the sodium hydroxide, excuse me, we know that if it's 0.00267 moles of the acid, it's going to neutralize it by the same amount of the base. And we know that because in step 2, you had a 1-to-1 ratio of hydrochloric acid to sodium hydroxide. So because of that, we have the same answer then for our base. Step 5 then says calculate the concentration of hydrochloric acid. So I'll erase what I have up here. And because it's a 1-to-1 ratio, we can use this equation of MV is equal to MV of acid to base, and only because we know this is a 1-to-1 ratio. So we'll get in a little bit into another lecture about what happens if it's not 1-to-1. So when it's a 1-to-1 ratio, I'm looking for my molarity of my acid, so I'll circle that. I know that my volume of my acid is at 25 milliliters. The molarity of my base is 0.12 molarity, and the volume of my base is 22.3 milliliters. So when I calculate that, multiply those, divide by that, I get the concentration of my acid to be 0.107 molarity. If you rounded it up, you would get 0.11. I would suggest to use 3 decimal values for your precision. Well, let's flip the page really quick, and we'll do an example. If we were in lab and we knew that that was, in fact, a 1-to-1 ratio, how could we determine that in lab? Well, again, since we know that it's a 1-to-1 ratio, again, 1-to-1 ratio of acid to base, hydrochloric acid and sodium hydroxide. The given information I have here, you need to read what I gave you. And this is after you saw the titration video posted by Flynn. 18.42 milliliters of hydrochloric acid. It went down to 36.92 milliliters. So you do have to subtract the difference so you know how much of base that you actually use to neutralize into the acid. So this is where the values are right here. You're going to subtract those two values to figure out in this acid, how much did it take, those drops of base, how much did it take for it to actually neutralize? So by subtracting it, that's how you can figure it out. You're given that you're starting at 20 milliliters of hydrochloric acid, and I do give you the concentration of your base that you're adding at 0.1 molarity. So in this, you are also trying to solve for your MA. So you can put in 18 milliliters is the volume of the acid. That's how much you're starting with. 0.14 M from molarity. 15.3 is the subtraction of milliliters. And you end up getting 0.119 molarity of your acid. All right, if you have questions, you can practice one of that. And then if you have questions, either email me or text me through Remind.